Okay, so in this video, we're going to talk about significant figures and how to find them. I'm going to call them sig fig for short. Now, we're going to deal with zeros and decimal points, so keep that in mind. I'm going to go over the different rules. The first rule is zeros to the right of a decimal point are always significant. So if we take the first number, for example, the 8, we only have one sig fig. If we go to the second one, remember, zeros to the right of a decimal point are always significant. So this 0 is significant, and then this 8 is significant. So every number other than 0 is always going to be significant. So this one has 2 sig figs. For the 80.0, we have 1, 2, and you guessed it, 3. So 3 sig figs. Now we have one like this one, 8.0000. All of those zeros are always significant. Remember, they're to the right of the decimal point. So we have 1, 2, 3, 4, and 5 sig figs. For the last one, we're going to see that every zero that's like these two that are trapped, so those zeros are trapped, they are always going to be significant. Plus, they're also to the right of the decimal point. So we have 1, 2, 3, and 4 significant figures. So 4 sig figs. Moving on. Okay, we're going to see that for the second one, zeros to the left of the first non-zero number. So any number other than 0 is never significant. So for the first one, you have 0, 0, 1, 2, 3. Remember, these zeros, might as well erase them. They are not significant. However, these are 1, 2, and 3. So we have 3 sig figs. Over here, same thing. All of these zeros, erase them. We still have 3 sig figs. And over here, so we have all of these zeros. Again, they are not significant even if I have that decimal point. So might as well erase them too. So I still have 3 sig figs. In this case, it doesn't matter if the decimal point's present. If it's to the left of the first non-zero number, it is non-significant. Moving on. Alright, so here we have zeros at the end of a number without a decimal point are never significant. So trapped zeros are always significant. Two different things. So we have, let's say, 1, 2, 3, and then 0, 0, 0. We have only 1, 2, and 3 significant figures because these are not significant. So we only have 3 sig figs. However, if we take that same number, 1, 2, 3, and then put 0, 0, 0 and a decimal point, now these zeros become trapped by this decimal point. Because they become trapped, now we have 1, 2, 3, 4, 5, and 6 significant figures for this one. So what does that decimal point mean right here? It means that we've measured exactly to 123,000. However, in the upper one, we are not sure we measured to exactly 123,000. We only have an estimate. So that's why we only say we have 3 significant figures on top and 6 on the bottom. For the fourth rule, we have zeros in scientific notation are always, always, always significant. First one, we have 2 sig figs. Now, you're not going to take this into account. None of this into account. No. We're not taking that into account. We don't care about that. Might as well erase it because we don't care about that right now. We only care about the numbers before. So in the second one, we have 1, 2, and 3 sig figs. However, remember that for scientific notation, you always need to have a number other than 0 in this place to the left of the decimal point. So this one doesn't matter. That 0 doesn't matter. So here in that one, we only have 1 sig fig. For this third number to be significant, we would have to write it like the first one. All right. So for the last one, we have 1, 2. That's a trapped 0. Remember, that one's trapped. 3 and 4. Why did I choose this one to be a significant figure? Because it's to the right of the decimal point. And zeros in scientific notation are always significant if that scientific notation is written properly. So we had 1, 2, 3, and 4 sig figs. We have that when adding or subtracting, the answer should always have the same number of decimal places as the quantity with the fewest number of decimal places. Okay, what do I mean by that? So if we have 3.14, we have 3 significant figures. For 5.1, we only have 2. So if we add that, we have 4 to 0.8. We're gonna write that number to the quantity with the fewest number of decimal places. So we would only write 8.2. We wouldn't write the 4. So our final answer would be again 8.2. Okay, so moving on to the next one. Same thing. Even though we have 3.14 with 3 decimal places and 1, 2, 3, 4, 5 significant figures for 3.14 had 3 significant figures, 2 decimal places, and 10.158 has 3 decimal places and 5 significant figures, so we will only write to 2 decimal places. So we would have 8, 5 plus 4 is 9, 2.31. So if we would write it to 2 decimal places, we would write this last number, we would have to round up because there's an 8 right here. We would have to round up, and then our final answer would be 13.30. Remember 30 because we have to write it to 2 decimal places. For the last one, it's a subtraction. So I would have to write an imaginary 0 right here to subtract, but I would still make it to 2 decimal places. Okay, so if we do that math, we would have 10 and then 13 and then 10 again and 2. So 1, 4, 1.0. So remember 2 decimal places. So I would cut it off right there. Remember, this 0 is a non-significant because it's to the left of the decimal point. So our final answer could be 0.14 or 0.14. Doesn't matter. Since we don't have to round because it's a 1 right here, we would just write 0.14 or 0.14. For the last slide, for multiplication and division, the answer should have the same number of significant figures as the least precise measurement. Okay, so what do I mean by least precise measurement? So if we have 1 and 2 significant figures, remember we only have 1 significant figure in the 3, so if we multiply 5.2 times 3, we would get 15.6. Now, we need to have only 1 significant figure. This, you guessed it, it would be this one. Now, what we would do is, since we have to write it to this significant figure, we would round up because that's a 5. So we would write, our final answer would be 20. And just 20. Why? Because remember, there's only 1 significant figure, seeing as there's no point right here. Since there's no decimal point, that means that it's only 1 sig fig. So that's good. Okay, so for 6.1 times 5.2, we get 31.72. Now remember, 1 and 2, 1 and 2. So 2 significant figures, so right here. Now, we would have to round up because there's a 7, so our final answer would be 32. And yes, there's 2 sig figs, so that's correct. For the last one, 6 divided by 4, we get 1.5 exactly. And since we get 1.5 and we only have to put 2 significant figures instead of 1, 2, 3, and 4, that would be our final answer, 1.5. Now, if we would have had 6.00 divided by 4.000, remember, so we have 1, 2, 3 significant figures versus 1, 2, 3, and 4. We would have to write it to 3 significant figures, and we would get 1.5 exactly, but then we would have to add that 0 at the end to make it have 3 sig figs, and then we would have this, the same number of significant figures as the least precise measurement, which would be 6.000.